Please make sure you have your copy of the assignment Experimental Design Diagram. What I'm going to do in this little demonstration is show you how to fill in something I call an experimental design diagram that's useful for looking at how the different parts of an experiment fit together. Now, some of the things that are on here will look familiar, and some of them might be some new terms. So what you're going to do today is learn how to fill in this information for an article that describes an experiment done in science. It's on the next page. It's called Got Germs. It's about an experiment done to test something about washing your hands. And there's an example of one of these already filled in that's based on another article in the packet about quitting smoking. So you can read through here and you can look at the example that I filled in to see how this might work. Where did I get the information that I used to fill this in? But before you do that, let's just look at some of the things that are part of the experimental design diagram. I'll show you the terms that are in the boxes using, as an example, an experiment that we did last week about why do things burn. So looking up at the first part, the hypothesis. Hypothesis is an explanation or a statement, not a question, something that you can test. It comes from a question. Our question last week was, why do things burn? A hypothesis is a statement. We were testing this statement, that things burn because they lose phlogiston. It's not a question, it comes from a question. It's something that can be tested. So when you fill in an experimental design diagram, when you fill in the hypothesis part, you might start by thinking about it as a question, but the hypothesis is your answer to the question. So after the hypothesis, then we design our experiment and we divide our trials up into two types. One type of trial is the experimental trial where you do the thing that you're testing, and the control trial where you leave out the thing that you're testing. The independent variable is the thing that you are changing or manipulating in your experiment. So in our experiment where we were testing why do things burn, we had the independent variable what is in a crucible. So we had crucibles, and in the crucibles we had either matches or magnesium, or we had nothing in our control. So in this one, what's our experimental trials? They include burning something. Our control trial includes not burning something. So if I were writing down what is the experimental part of the independent variable, it would be burning magnesium or matches. In the control, it would be burning nothing. That's what we changed or manipulated to make the two parts of our experiment, the experimental part and the control part. That's the independent variable. But in the experiment, we kept some things constant. Things that were the same across all of the trials were the crucibles. We always used the same crucibles in all of the trials. And we also burned them for approximately the same time. So if I were describing the constants, or what was kept the same in the experiment, it would be the crucibles or the burning time, and the burning time. Finally, we make note of the dependent variable, the thing that we're going to measure or look for, what is going to be our data. In that experiment, the data that we took was the mass of the crucibles and how the mass changed or not. So the dependent variable is what your data are about, what response is going to be observed. And you make predictions about those. You make a separate prediction for your experimental and for your control trials. We predicted what happened, that is, if something loses phlogiston as it burns, that the mass that we measured in the dependent variable would decrease because something goes away, but the control would have no change because there was nothing to lose. So this is an example of the terms that are part of the experimental design diagram. When I'm filling in one of these, I keep track of what I changed or manipulated. I changed what was in the crucibles. And for the experimental ones, we burned either magnesium or matches or nothing. And for the constants, what we kept the same were the crucibles and the time frame. And for the dependent variable, we measured the mass of the materials before and after burning. And we predicted the mass would decrease or stay the same. And then finally, you record what did you observe, and you see if your observations and your predictions match. And if they do, then your evaluation is to accept or support the hypothesis. And if they don't, then you reject the hypothesis. So parts of this should look familiar from what we've practiced. The new terms are independent variable, constants, and dependent variable, but we've been working with these parts of the experiment. Now you have something to use to put the names to those parts and organize them. So what I'd like you to do is, again, to try to fill out using this article about an experiment dealing with washing your hands. Can you find the hypothesis? Can you find what was changed and how two groups were set up? What was kept the same in both groups? What data were taken or observed? And what's predicted if the hypothesis is supported? And then what did they actually find, and what does that tell you about the hypothesis? We'll take a look at the results tomorrow, and we'll also finish our analysis of the data that you collected last week in the second part of our Why Do Things Burn experiment. So I'll see you tomorrow.